Thank you. It's very much an honor to be here with everyone in person. So thank you for leading us into that. I'm not a neuroinformatics, well, I'm a neuroinformatics person, but I'm not a neuroscientist. That being said, I hope you won't hold it against me, but I think there's some things that we can all learn from each other to motivate what we're trying to do. So what we're going to do today is really give you a highlight, and I encourage you to take a look, if you haven't already, the hands-on session inventory of options you have available to you this afternoon, and see on, for example, how to work with the BigBrain data that you want to do in your scientific endeavors, but using some of the scientific tools that we have. And what I'm going to talk about a little bit is some of the generalized infrastructure, but a little bit in the context of how to use it from two different methods, using something called DataLad and also within CBRAIN. Great. So you look at the challenges that we have in data science, whether it's neuroinformatics or just a generalized science period. You're dealing with volumes and volumes of data. You want to be able to find methods to actually do the compute on that data. And you're also going to want to work with your collaborators to actually get organized, manage the results that you're dealing with. Whether it's in health research or other endeavors, these are common challenges. And really you want to build as part of that, though, some infrastructure that's based upon services and other physical infrastructure, but also software infrastructure to actually accomplish that science. Now, we can look in the neuroscience space. There's a wide range of different challenges that are there, ranging from all the acquisition phase all the way through. And of course, there's the more human side, which is things like obtaining funding and so on. But I'm going to really focus on maybe some of the ones that are highlighted in red here, which is really, like I said, building that interoperability layer to deal with how do we actually have these tools working together? How do we ensure that the tools that we're running to produce the science are reproducible? How do we ensure the security of the data that we're dealing and handling? And also, how do we deal with the heterogeneous set of data or systems that we're working with, whether it's you're on your laptop, large-scale HPC compute, your workstations. That provides a wide breadth of things that you have to try and manage across, which can provide challenges in trying to moving back and forth. Then you want to be able to say, well, in my data, the provenance, where is my data coming from? Where is it going to? How do I link between my task that I'm running on to that data? These are things that you can write down in a notebook. It gets messy very, very quickly. And then you want to manage the end-to-end process. You take your data, how do you bring it through the end-to-end workflow of it? Processing, pre-processing, analysis, visualization. Those are challenges as well, which can mean lots of steps, lots of reproducibility challenges. And so some of the tools that I'm going to talk about a little bit here address some of those and bring to you methods by which you can actually then focus on the science and move forward. So as a researcher, you can have your different data structures. You're saying, okay, how am I going to actually work with this data? Now there's, in generalized terms, there's two real categories you can deal with. You want to, though, in the end, have, as I said, that's something that's easy access to the data. You want to be able to actually work with the computing side of things. And as I said, ensure that reproducibility. But at the end, you're also going to want to scale up. How do you go from just running some sample tests on a few subjects all the way up to the entire study set of subjects? And then how do you collaborate? Well, you can say, what is the question? How do you deal with that data? Now, there's classic methods. Well, typically what many people, including myself over the years, have learned. You start off at the command line. You're working on the login shell of an HPC system. You go through and you learn all the tricks and the magic of using that. And then you can also do other, not to say there's not a continuing spectrum, there is actually a spectrum of needs, but on the other side of the spectrum from a solution point of view are web-based tools that actually lower the barrier to entry, make it much easier for you to actually then focus on the science, but still achieve the 4 outcomes that I listed at the screen below. So what we're going to talk about during the hands-on session particularly, but I'm just going to highlight a couple of the features of it. Doing the command line side is really supported by something called boutiques together with DataLad. And boutiques, as I'll describe in a minute, is really more from the processing side of things. It's not exclusively the tooling, but then also the DataLad, which facilitates the data visibility and the data access. Or on the other side, even though the components of infrastructure I talked about before of DataLad and boutiques are part of it, CBRAIN provides a nice single pane of glass, one view that actually lets you work with a web interface, but it also is very powerful if you want to use programmatically to do the same sorts of things. So these are the two things that we're going to focus on during the hands-on session. But I'm going to just give you a couple highlights about pathway number 1 up top and what that means for boutiques and DataLad, but then also some of the parts from the CBRAIN point of view. So boutiques like I said, makes it a very easy way to describing the tasks that you want to run, the tools, and it basically provides a framework for lots of easy checking. So it's a JSON formatted file. It actually has built-in capabilities for tool viewing and importation, but it also validates things very easily. So that way you don't have what you would doing if you're on the command line typing yourself. 9 times out of 10, if you're like me, you're going to actually make a mistake and then you have to go back and try it again. There's a lot of validation steps that Boutique takes care of for you. It also, in the end, provides capabilities of publishing into open publishing platforms like Zenodo, which is very nice. So then you can actually then, as part of your publication, you have traceability and showing exactly what data you've been using, but also the tasks that have been run. So you can look at using boutiques from a number of perspectives. If you're building a tool as a developer, you can actually go through and create the actual containerized tool and build a descriptor for it, which other people can use. But then the other side is the actual consumer. The scientist is going to come through. You can actually then take descriptors written by tools and other people, use that and build it and import it into your own scientific platform. And you can then run it across, like I said, any heterogeneous set of systems. Taking advantage of that, combining the actual boutiques part with the DataLad. DataLad is generalizable and across data sets, and it allows it for use across command line as well as through an API layer, but it takes advantage of things that we're also very familiar with. Many times we're using Git and GitHub already. It takes advantage of some components of that for managing and version controlling the data. And it also provides mechanisms for transporting that data across systems. So as we'll see in the hands-on tutorial, there's methods by which we're going to access the BigBrain data, view it, and download it and work with it. So it really facilitates that reproducible data analysis. So that's kind of is the second part, like I said, of that first pathway using the command line interface. Now you can say, well, okay, great, that's fine, but there's still a learning curve with all these. If you really want to look at the other options through the web UI interface, like I said, CBRAIN provides a nice method for bringing that barrier of entry down really nice and low so you can then focus on the science, but all at the same time is flexible. So I'll just say some information about that. So that with this, you can actually transition from what's on the left side and focus, as I said, through that web interface that is a single pane of glass view and makes it easy by CBRAIN taking care of what's called the orchestration layer. It takes the task you want to run, the data you want to run it on, and brings those two together and manages it all through wherever that hardware may be. You're running it on your supercomputer, in your lab, elsewhere. You'll see it takes care of all these things and facilitates, like I said, these 4 main objectives. To do that, it really is a multi-tiered structure. It takes methods by which you work with the data, work with the tasks, and work with the actual infrastructure it's going to run on. So you, as the user, you actually interact with these 3 layers, and then you can make a decision. Okay, what data do I want to work with? You select it through the platform user interface. You then select the tool you want to run it on, and then you just make a decision where you want it to run, again, through a single click, essentially. You're actually, well, you see it through multiple clicks, but with one click of the button in the end, it will run on that infrastructure. And the good thing is that it links together multiple data sources. The data sources can be from open repositories, like we have the Canadian Open Neuroscience Platform. It talks into other infrastructures like what we have connected in McGill for the UK Biobank, and it also leverages already in the back end software infrastructure like DataLad. And again, it's also very powerful. So if you're developing, you're trying to iterate through things, you're trying to debug some things through notebooks, as we'll exercise this afternoon. It also supports use in Jupyter notebooks. And finally, it is really, again, that interoperability layer. It ties into systems such as called LoRa's, more for the multimodal data acquisition. So altogether, then, it can actually handle, through this ecosystem of tools, the collection phase all the way through to analysis. So just to give you a few teasers for this afternoon, what you'll see, as I said, it provides a single pane of glass view. You get a nice web interface, you see your files, you see your tasks that you're managing. It's all easy to work with. So that way you can actually have your data across a wide disparate set of systems across the globe. You don't really need to necessarily care if it's on system A in Los Angeles or somewhere in the cloud. It provides that single view to you all within the web interface. And nicely, it has a lot of built-in visualization tools, such as something called BigBrain browser that was developed as part of CBRAIN several years ago. With that, you don't have to download the actual results for viewing to localize on your computer. You can actually work with it directly within the web browser to do your volumetric, your surface viewing directly within that. Now, within the tool space, it continues to grow. Over the last year, we've added about 10 new different tools, but it really covers the full range of modalities that are presented here on the screen. And it does this by actually working with containers So standards are really based upon the containerization, so it's something that's accepted in the scientific community, but also in industry, to use those containers for really portable systems across the different compute elements. And uses, again, on top of that, boutiques for the standardized interfaces to talk with those containers. So in the end, CBRAIN really brings all these things together, the tools, the compartmentalization of those into containers, the description, and then manage it across the entire set of systems. And I'll just give, like I said, and talk about the notebooks, anything you can do from the web UI view, you can do programmatically. So again, we have modules online where we've given tutorials about how to use Jupyter Notebooks directly with the CBRAIN API. So all the things that you've done interactively through the web UI, you can do programmatically as well. So it makes it very versatile and very functional. It started around 2009, just to give you a view of the growth in the user space. It's right now, CBRAIN has what's called around 93 different sites, 193 sites across 32 different countries. So we have about 1,400 users, and that's continuing to grow. So that's a significant base of the community taking advantage of this capabilities that it brings. And it connects significant compute resources, as I mentioned, whether it's in the Americas, Europe, and Asia. And particularly one to highlight for the BigBrain is the initiative that we have together with the ULICH side. So we have actually already configured within CBRAIN the deep system specifically as the first phase, and it's going to move on to the Joule system so that we can have that transposability of the workflows through CBRAIN across over into the ULICH side, and then therefore connecting in eventually to the eBrain side of things as well. So you can see it covers the entire breadth of resources, large scale across the globe, and even, like I said, touches into the cloud computing space depending upon what people's particular needs and capabilities require. And just you can see, well, this is a large set of infrastructure. Just in the last year, if you look at the aggregate amount of computation that has happened, there's been about 500 core years, so if a processor running for an entire year, about 500 of those has been consumed, so a significant amount of resources have been consumed, and it's managed over nearly 200,000 tasks by this point in the last year that have worked its way through the system. And again, all these are recorded and visible to the user to go back and have that full provenance information linking their input data, the task, and to the output. And lastly, I'll just highlight some things in terms of the volumes of the data sets, the types. Within the right-hand side here, you'll see the review that you have in CBRAIN. You'll see some of this afternoon in the hands-on workshop. So all of these, and the one in the brownish color, are really open data sets, which includes the BigBrain data sets that are there. But we also, like I said, have that linkages within other platforms for open data sharing, such as the Canadian Open Neuroscience Platform, COMP, which has even recently been updated to even provide direct links within the platform itself to CBRAIN for task execution. So when you select your data sets, such as the BigBrain, you can actually transition seamlessly from the actual data view into the task launching mechanisms to give you that end-to-end flow. I'll just wrap up with just a couple of slides to talk about where we're going from an interoperability point of view. I've talked about really, the two pathways, command line, different tools, but then also the web UI with those tools itself. But as an ecosystem, we want to build something that together is interoperable. It's not something that's standalone, independent. It actually needs to be able to work together to talk with other systems and to actually then facilitate the building of the community. And to do that, there's a range of services that we need to provide. Right? We need to be able to manage the data. We have to actually then link that to processing. We have to actually be able to enable sharing of people's results with each other and also the wider world. And then we have to provide means of exploring that. And building upon the actual linkages that we first developed as part of the interoperability between things like LoRa's for the data acquisition side and CBRAIN for the processing side, at McGill about 4 years ago, we started basically unifying those into a common view, a single ecosystem that we can make available, something called NeuroHub. And what that presents is essentially a single entry point by which users can access services and capabilities that bring all these together to allow the flow of their work across all these different components that they need to use. So as you can see here, it covers that range of ecosystems. So things like I said, the DataLad and the boutiques, those are components of the ecosystem that we make accessible through NeuroHub. So I invite you to come, we can talk about that, but what you're going to be exercising this afternoon will be some elements, like I said, of what NeuroHub is. So just to wrap up, I hope you've seen that, even for your particular space and the neuroscience elements, you're going to obviously be dealing with large volumes of data into compute, and you want to bring those together and build those collaborations. With that infrastructure, what I've described between boutiques, DataLad, the CBRAIN side, and the NeuroHub components, those infrastructures and services are being brought together to help accomplish that science. We try and make those, like I said, core pieces for reproducibility and interoperability, so that's the important element in trying to bring these things together. One last point, if you're thinking, okay, with a name like CBRAIN, it's CBRAIN focused, but we built it in such a way that it is actually agnostic to the type of science they're doing, so that's one of the things that people should be aware of if you're also talking with some of your colleagues outside this particular domain. But like I said, it's built on standards that lets us have a greater space of adaptability. So we really want to, like I said, build bridges, not build islands, and this is a great way of doing that. So I encourage you to take a look. We have our websites, our GitHub pages, all open source software. With that, I'll acknowledge, like I said, certainly the large amount of contributions come from the team that I work with and led by the group of Alan Evans. I'm very thankful for the great work that everyone's doing, and I'm looking forward, again, like I said, if you haven't signed up already, for the hands-on sessions this afternoon. Thank you for your time.